Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating article on Composable SQL, a proposal to revolutionize how we write and test SQL queries. It's all about tackling the major pain points of traditional SQL, especially when it comes to testing and managing business logic. Exciting stuff!
I'm eager to hear this. SQL testing has always been a huge challenge. What are the core issues the article highlights?
Exactly. The article starts by pointing out the near impossibility of effectively testing SQL queries. Even the simplest query requires setting up a massive, often irrelevant, dataset. Imagine testing a query that pulls a book title. You need to populate every single column in the books table, even if those columns are completely unrelated to the query's output. It's a combinatorial explosion of test data.
That's a really good point. It makes testing incredibly cumbersome and inefficient. What about business logic? How does that factor into the problem?
Right. The article argues that in normalized databases, a lot of business logic lives within read-time queries. Things like calculating a pallet's payload weight in a logistics system. That's business logic embedded in SQL. The author explores three common approaches: duplication, denormalization, and views. Each has significant drawbacks.
And what are those drawbacks? I'm guessing duplication leads to maintenance nightmares?
Precisely. Duplication means you're rewriting the same business logic in multiple queries. A change in the logic requires updating every single instance, leading to inconsistencies and errors. Denormalization, while improving query speed, introduces complex data integrity issues and increases storage costs. Views, while seemingly elegant, often suffer from poor query optimization, defeating the purpose of using them.
So the author proposes a solution. What's the core idea behind Composable SQL?
The proposed solution is the introduction of functors, composable query fragments with statically typed interfaces. Think of them as functions for SQL. They allow you to define reusable, testable pieces of business logic that can be combined and used in various queries. This addresses the testability problem because functors operate on interfaces, not concrete tables, allowing for much smaller, more focused test datasets.
That sounds elegant. How does it improve testability specifically?
Instead of needing the entire database populated, you can create small, fake tables that satisfy the interface required by the functor. You test the logic in isolation, without the overhead of a massive test database. The article even suggests using table literals in Postgres for even more streamlined testing.
Interesting. So functors essentially abstract away the underlying data structure, allowing for modularity and reusability. But how does this handle the performance issues associated with views?
That's a great question. The author acknowledges that simply nesting functors might still lead to suboptimal query plans. However, the solution is to filter data before passing it to the functor, using CTEs. This ensures that the functor operates on a smaller, already filtered dataset, leading to better performance. It's about controlling the data flow to optimize query execution.
So it's not just about modularity, but also about strategic data filtering to improve performance. This sounds like a significant improvement over the current state of SQL.
Absolutely. The article concludes that functors offer a path towards writing SQL that's fast, testable, and understandable through local reasoning. It's a compelling vision for the future of SQL development. The author even discusses potential implementation strategies, highlighting the challenges but also the potential rewards of this approach. It's a really thought-provoking piece.
It certainly is. This approach seems to address many long-standing issues in SQL development. Thanks for summarizing this insightful article.
My pleasure. And thank you for listening to Tech Bytes and News. We hope you enjoyed this deep dive into the world of Composable SQL. Join us next time for more exciting discussions on the latest tech trends. Goodbye.
Bye-bye.